In this section, we will discuss about different VPC failure scenarios. So the very first case is when the VPC peer link goes down. So the impact of this will be that the VPC secondary device is going to shut down all the VPC member ports and the VPC VLAN SVIs. Okay, so let's check it with a practical. So before we go into the details of the failure scenarios, I want to show you one more cool feature about the NEXUS CLI that we can use the colorful CLI in NEXUS. We just need to give one command. So if you already know about this, then it's fine. And if you do not know about this, then let's see it how it works. So we just need to give one command, that is a terminal color and then persist. So after you give this command, you can see that the CLI color is changed. And how does it work? If you go into the configuration mode, so your outputs will be in your default color. And let's say if you type any wrong command, let's say you type any wrong command, if you see enter, now you can see here that your color is changed. On the left hand side you can see the color is changed from green to red. If you type any right command, let's say you type interface ethernet 1 by 1. So now when you type the right command, then again the output on the left hand side, it will change to green color. Okay, and your all your output will be in the default color. For example, if I do a show uh, port channel summary, so now you can see your output is in a default color, right? And it's also very good to look at, because now you can see your command is in kind of a bluish color, and all your output is in black color. So it is you can see that the output is kind of differentiated. So this is how you can use a colorful CLI. So if you like colorful CLI, then you can use this with a simple command, that is terminal color persist. Okay, now let's go back to our topic. So that is the VPC failure scenarios. So let's see what is the role of this device. So N7K1 is the secondary device. If I go to uh, N7K2, if I do a show VPC role, so this is our primary device. Let's also make the CLI colorful for N7K2 also. I will do a terminal color persist. Okay, so now N7K2 is the primary and N7K1 is the secondary device. So as per the failure scenarios or the case one, when the peer link goes down, let's first of all let's bring down our peer link. So if I do a show port channel summary, so port channel 1 is the peer link, right? So let's bring it down. So I'll go to interface uh, interface port channel 1. I will do a shutdown. Okay, so our peer link is down, right? If I do a show port channel summary, so our peer link is down. Now you can see if the VPC member ports are down, right? If I go up, you can see here all your member ports were up, but because now your peer link is down and N7K1 is your secondary device, if I do a show VPC role, it is a secondary device. So that is why now all your member ports are down. Also, if I do a show IP interface brief, so your SVIs or your VPC VLAN SVIs are also down. You can see here protocol is down for SVI 10, 20 and 30, right? If I do a show VPC, now you can see your VPC 2 and VPC 3 both are down, and you can also see the reason here, that the VPC peer link is down. That is why both your port channel 2 and port channel 3, or your VPC 2 and your VPC 3 are down. Okay, so this is the first case. So which says that when your peer link goes down, so your secondary device is going to shut down its VPC member ports plus all the SVIs which are related to the VPC VLAN. Okay, so it is just to avoid the dual active situation, right? Because if the peer link is down, then they are no more able to synchronize over the peer link, right? So that is why, and your peer keep alive link is still there, right? If I do a show VPC peer keep alive, so you can see here that the VPC peer keep alive link is still there, right? So the peer is alive. So that is why the secondary device is going to shut down all its VPC member port just to avoid a split brain scenario. Because through the VPC peer keep alive link, it gets to know that the primary is still alive, right? So just to avoid any forwarding plane issues, it shut down its member ports, because the soul of the network is down. They were exchanging all the information related to MAC addresses, or maybe the ARP entries, HSRP messages, everything they were synchronizing over the peer link, and that is down. That is why via the peer keep alive link, the secondary device gets to know that the primary is still there. That is why, to avoid any forwarding plane issues, it shut down all its VPC member ports plus all the SVIs which are related to the VPC VLAN. So this is our first case. Now let's check out what is the second case. So this is our second case. In our second case, the VPC peer link is down. Okay, as you see in our first case, VPC peer link is already down, and after some time, the primary fails completely. Okay, so the impact of that will be that the VPC secondary device, all your member ports and your SVIs, they will stay down until the primary is back. Okay, so from our previous scenario, our peer link is already down. Now let's make your primary device completely down, and then see the behavior. Okay, let's go back to our devices. Okay, so I'm on N7K1, which is the secondary device. Okay, and what I have done is I have shut down the primary device. So I have shut down, I have power off N7K2. Now we can see that if we do a show VPC, our port channel 2 or VPC 2 and VPC 3, they are already down because of the peer link was down. And now, as we have checked the case number 2, if your peer link goes down, your secondary device is going to shut down all your member ports plus the SVIs, right? If I go to show IP interface brief, all your SVIs are down. After that, after this situation, if after some time your primary device completely fails, then we'll be in trouble, because your secondary device is not going to make your SVIs plus your member ports up until your primary comes back. You can see they'll stay down. Okay, and your VPC, they are not going to come up. Okay, so a quick fix of this situation is that we remove the VPCs. Okay, because if I do a show port channel summary, now you can see here that your all your member ports are down. So all your downstream devices which are connected to a port channel 2 or port channel 3, they will not be able to communicate, right? So all your traffic will be black hole, or you can say your links are down, right? So all your VPC member ports are down, so there will be an outage. So a quick fix of this situation is that what we can do is that we remove the VPC configuration. So if I do a show VPC, and if I do a show run interface port channel 2, show run interface port channel 3, so still we do have the VPC. If I do a show port channel summary, so all your VPC member ports are down. So a quick fix of it will be that we remove the VPC configuration. For example, if I do a show run interface port channel 2, so I will go to interface port channel 2. I will say no VPC. Okay, now if I check again, show port channel summary. So port channel 2 will eventually come up. Just wait for some time. Show run interface port channel 2. VPC is still there, it is not removing it. Show run interface port channel 3, show VPC. Show run interface port channel 2, somehow it's not removing the VPC. Let's try it on port channel 3 maybe. If I do a interface port channel 3, no VPC 3. Show run interface port channel 3. Yes, so VPC is removed from port channel 3. Now if I do a show port channel summary, now you can see because port channel 3 is no more a part of VPC. Now you can see the difference that our ports in port channel 3 are up, right? So Ethernet 1/5 and 1/6 are up now. So this is a quick fix that we can apply just in case our primary device fails and the member ports and the SVI stays down in the secondary device. So this is a quick fix that we can apply. So we can apply the same fix for all of our port channels. But see, this is not a practical solution, I would say, because in a live network you can have a lot of port channels into the VPC, right? And so just in case we need to apply this solution, what we can do is quickly we can take the backup of our device, and then we can remove the VPC configuration. Okay. So case number 3 is when, let's say, there is a power outage in your data center, and both your peer devices went down, but only one device comes up. Okay, let's say your second device, maybe the hardware got faulty, and it stays down, but only one peer comes up. Okay, in that case, your device is not going to your other device is not going to work, because all your VPC, it will not be able to establish the VPC. Okay, because if you have gone through my previous videos wherein I have discussed in, I think, on the lecture 1 or 2 regarding the configuration of the VPC. So it follows some steps, okay, and the order must be followed in that case. So the very first case is the feature VPC, right? The VPC feature must be enabled. So the feature is already there, right? That is not an issue. But the second case is that the VPC peer keep alive link. Now, because your other device is already down, and in that case your VPC peer keep alive is not going to come up, then the next steps are not going to be completed. That is why your VPC will stays down. Okay, now let's see it with a practical. So I'll go to our devices. So this is our N7 cable, and now you can see both the port channels are up. And if I do a show VPC, so port channel 2 and port channel 3 both are up. On your primary device also, if you do a show port channel summary, everything is up. So now I'll pause the recording. I'll go ahead and I'll power down both of the N7Ks, and then I'll bring up only one device, and then we will see what will be the effect of that. Okay, so now both our devices were down, but I just bring up only N7K1. So if I do a show port channel summary, now you can see all your ports are down. And if I do a show VPC role, sorry, show VPC, role. Now you can see here that the VPC role is not established, right? Here, the VPC role is not established. So that is why all your port channels will be down, right? Because if I do a show port channel summary, so all your ports will be down. And because in our previous section, when we started the VPC series in I think in lecture 2, when we do the VPC configuration, then we studied this part, right? First of all, this order must be followed, only then your VPC member ports can comes up, right? So we discussed that your VPC member ports will come up only when your VPC peer link is up, and your peer link will come up only when your VPC peer keep alive link is up. And your VPC peer keep alive link is not going to come up unless you create the VPC domain ID. And your domain ID will be created only when you enable the feature. So now in our case, and when N7K1 is up, because this VPC feature is already enabled, right? And VPC domain ID is also there. So both your steps are completed. But the third step, that VPC keep alive link, because of the second device is down, your VPC keep alive is not going to come up. That is why you can see here, if you go to N7K1, that your state is known established, right? When we checked the show VPC role, it is not picking up any role, because now you can see that this is the only device in the network, so it must be the primary device, right? Because the secondary device is already down. But it is not because not picking any role, because the order is not completed. Your VPC peer keep alive link is not live, so that is why your VPC is not working. So in this situation, because now your both devices were down and only one device comes up, and all your downstream devices wherein you have configured the VPC, that ports will stay down. So now you don't know, right, that your one device that went down, its hardware is faulty, and you don't know how much time it is going to take to replace that device. So the quick solution of that is the same that we discussed, right? What we can do is, I will just do a no feature, or I will do a no VPC2. Else what we can do is, quickly I can do a no feature VPC, and if I do a show run interface channel 2, so the VPC configuration is erased, right? If I do a show port channel summary, now we can see both our port channels are up. So just make sure that before you remove the VPC configuration, or if you do no feature VPC, just take the backup of your device, so that just in case when your secondary device or your second device comes up into the network, then you can quickly paste the VPC configuration. Okay, so this is the quick fix that we can apply for this kind of disaster as well. So these were the three cases that we discussed, but we can see that this is not a practical solution of it. So in the Cisco NX OS, we do have one feature that is the VPC auto recovery feature that we can use, that will take care of all of these situations. So whatever we have discussed today, let's see a quick diagram of that. That will be more easy to understand. So before we go into our diagram, I just want to show you one more thing, because that will be used in that diagram. So if I do a show VPC peer keep alive, so there are two timers. One is the keep alive timeout. This timer is of 5 seconds. The second timer is keep alive hold timeout, that is of 3 seconds. So that we are going to discuss what is the use of these two timers. So basically these two timers are going to play a crucial role when our peer link goes down. So now let's go to our diagram and see all the details that we discussed today. So this is our diagram that we will discuss. So if you see here that the peer link goes down. So once the peer link goes down, we can check what is the VPC role. So if you see here the primary device, so the primary device is not going to take any action, right? So all its VPC member ports and the SVIs, they will stay up. Now let's come to the secondary device. So when the peer link goes down, the secondary device, for the first 3 seconds, you can see here it is going to ignore the keep alive. Okay, that is called the keep alive hold timeout. And what is the value of that? It's 3 seconds. So for 3 seconds, it is going to ignore the keep alive from the peer device. Now your keep alive timeout timer will start, and this timer is of 5 seconds. So within this 5 seconds, if your secondary device receives any hello, not hello, the keep alive from the peer device, then it will get to know that the primary is still alive. That is why it is going to take the action that we discussed, right? It is going to bring down the VPC ports and all the SVIs which are related to the VPC VLANs, right? And if your, let me clean it. And once it brings down all its VPC ports and the SVIs, and after some times, let's say your primary device also fails completely, right? Then what is the action it is going to take? All its ports will stay down, right? And all its SVIs are going to stay down until the primary device comes up, right? The second case is that it did not receive any keep alive from the second device. So after this whole time, or the keep alive timer expires. So after this 5 second, once this timer is expired, so the secondary device assumes that your primary device is down, and now it will become the primary device. So now it will start doing the role of a primary device. So this was our three cases that we discussed. So in our next section, we will discuss about the uh, VPC auto recovery feature, and we'll see how VPC auto recovery feature is going to help us in this kind of disaster that we discussed today. So see you in the next section.